Let's look at the position time graph for our acceleration. So we have set of scenarios over here. So we need to observe position time graph for positive acceleration. Say we have an object which is already moving to the right. And what is happening? Observe, every second the distance it's covering, it's increasing, right? So this is a case of what kind of acceleration? Positive acceleration. Now the question is, how will my position time graph look like? So it looks curved in this manner, right? So it's basically concave. If I am looking from top, it is concave. Actually, if I shade this way, it's concave, right? It's basically moving up in this direction. So it's kind of moving. Okay, I can do it here itself. The graph looks like this. Moving up. Okay, then I'll take up negative acceleration now. Again, I'm not showing all the scenarios actually. Again, observe what is happening. What's happening with the turtle? It's slowing down, is it not? So this is an example of negative acceleration. If right is positive, the object is slowing down, means what? The force of direction is opposite to the motion. So it's to the left basically. So direction of acceleration is to the left. So it's a negative acceleration. And so you can see that it is bulged out. So it's trying to flatten basically. So this is the case of negative acceleration. That's how the graph will look like. Again, guys, I'm not taking the screenshot. You need to pause and do it because generating it again will be a headache. So something like this is what it looks like. Even a small writing over there will help. And finally, we have zero acceleration. So you can see that object is continuing with the same velocity because it's covering same distance every second. And so this will be just a straight line. So this is how a position time graph looks like for, well, we just showed around 3 cases. So that will be a flat line. Let me show other cases as well actually. I'll show the other positive cases as well. Okay, you're not able to see it. Let me cancel this. So you can see that acceleration is positive, even though it was moving left. So for me to do that, I need to change few things actually. Okay, let me show this, then we'll see if that makes sense to you guys. The object is moving to the left actually, but what's happening? It's slowing down. So our force is making it, the force has to be right. And so the acceleration is right. See, the value, please don't ignore this. That's what I told. There will be some hiccup at the start. So you can ignore that. This is what you guys have to look at. Okay, it's flattening. It's kind of flattening and it will go concave and it will go up. So basically your graph for this technically will look like this actually. So with time, it will go flat and it will start going up. Okay, I can actually show that. I just have to change one thing about the calculation. Okay, let me try this now. I think I got it. Let me do it. Right? Slowing down, slowing down, slowing down. Eventually, since our force is in the right direction, can you see that? Yes, it's actually overlapping with the same thing again and again. That's why you're not able to see it moving forward. But can you see the curve? See, it went from 0, it went negative, negative, negative. Still negative. All of this space is negative. If I keep continuing, it will go past and it will start going to the right direction. So end of it, it's this. Over here, it would be something like, it would be, again guys, this should be commonsensical to you guys. All of this you guys can try. It would be opposite of this very case. And this would be opposite of, diagonally opposite. So this case will be something like this actually. So these are the graphs. These are all your position time graph. So displacement time graph. Time, displacement, displacement time graph, displacement time graph.